Today we are going to talk about the future potential of hydrogen fuel cells. A hydrogen fuel cell uses hydrogen and oxygen to make electricity, heat, and water without the production of CO2. This figure from the International Panel of Climate Change Special Report for 1.5 degree warming released in 2019 shows the estimated global warming relative to pre-industrial times due to anthropogenic effects such as CO2 emissions. As of 2017, the estimated monthly global mean surface temperature has risen about 1 degree Celsius from pre-industrial times. This figure shows the reduction in global emission timeframes and the resulting probability of limiting global warming to 1.5 degrees Celsius. The International Energy Agency released a report in 2019 titled The Future of Hydrogen. The report states that hydrogen technology can reduce emissions in high-emitting, difficult-to-electrify sectors, improve air quality in urban centers by decreasing tailpipe, commercial, and industrial emissions, improve electrical storage capabilities, and strengthen energy security of nations who import large amounts of energy. The report also states that hydrogen can be produced by many fuel types such as renewables, nuclear, natural gas, oil, and coal, and there is a great opportunity to clean up the production of hydrogen with carbon capture or renewably powered electrolysis. The left side of the diagram shows the hydrogen production and the right side of the diagram shows the hydrogen demands. The hydrogen costs from hybrid solar photovoltaics and onshore wind systems in the long term are shown in this figure. The red and blue areas represent regions with lower and higher cost per kilogram of hydrogen. The report states that hydrogen creates clean industry for developing nations as well as clean transitions for industry in developed nations. Recently, there has been exciting innovation in the global hydrogen industry. Germany introduced its first hydrogen fuel cell passenger train in 2018 and has another 14 on the way. In Korea, Hyundai Motor Group aims to produce 700,000 fuel cell systems annually by 2030. In Netherlands, companies Gasunie, GSB, and Shell aim to use offshore wind power to produce hydrogen with a capacity of 10 gigawatts by 2040. In the US, Plug Power has produced hydrogen fuel cells for forklifts and installed fueling infrastructure for giants like Amazon and Walmart.
Thanks, Matt. Within Canada, a feasibility study to transition the Ontario Go rail network, shown here, to fuel cell trains was conducted in 2018. The study deemed the transition to be both technically feasible and economically comparable to a typical overhead electrification project. Additionally, North America saw its first power-to-gas facility open in 2018 in Markham, Ontario, using up to 2.5 megawatts of excess power from the grid to create hydrogen gas, which can be reconverted to electricity or blended with natural gas to create a cleaner fuel. In BC, we have the longtime company Ballard Power Systems, who make fuel cell module stacks and backup power systems. Ballard collaborated with BC Transit and New Flyer Industries in 2009 to conduct a 5-year demonstration of 20 fuel cell buses operating in Whistler. The demonstration showed that fuel cell buses can be used to provide daily service in an urban transit operation and can contribute to the provincial government's climate action goals. Looking at the economic side of things, these two figures from the 2019 IEA report show the effects of both electrolyzer cost and electricity cost on the levelized production cost of the hydrogen in dollars per kilogram. From the figure on the left, we see that the cost of the electrolyzer itself has a larger effect at low usage rates, but becomes almost negligible at the full load hours increase. Conversely, on the right, electricity prices maintain their cost difference throughout the full operational range of the electrolyzer. This shows that in order to develop clean, cheap hydrogen production, it could be more important to focus on the levelized cost of energy of the supply of electricity, rather than bringing down the cost of the electrolyzer technology itself. Unfortunately, hydrogen is not the one-stop shop for a clean energy economy. First off, clean production of hydrogen is still very expensive, leading to virtually all of the global supply to be produced from natural gas and coal. The figure here shows production costs of 100 tons per day capacity in BC from a 2019 province-wide analysis. We see that the cheapest options are byproduct and steam methane reforming, with electrolysis from the grid being around 5 times the price per kilogram. There is also a lack of hydrogen infrastructure, making it difficult to build and implement new projects. Additionally, government regulations currently limit the development of hydrogen. Natural Resources Canada claims that the current lack of Measurement Canada approved devices for hydrogen metering and dispensing poses a barrier to retail sales in Canada. Although hydrogen shows promise to play an important role in emissions reduction targets both locally and globally, there is still a lot of work to be done.